I'll be showing my graphics programming project. It takes a snapshot from the camera, processes it step by step, and displays each stage in a grid. At the end, I'll also show how the face filter works. To take a photo, key press S, say cheese. The first cell always shows the live webcam feed. When a snapshot is taken, the image is saved and used for all other panels, so the results are consistent while the first cell keeps showing the live video. Here, the program converts the same snapshot into grayscale. While converting, it also brightens the image by about 20%. To achieve that, for each pixel, I calculated the grayscale value by averaging the red, green, and blue channels. Then I multiplied that value by 1.2 to make it brighter. Values exceeding 255 are clamped to 255, which is the maximum intensity a pixel can take. Finally, the same grayscale value is written back to red, green, and blue with alpha set to full. I've split the original snapshot into 3 color components. Each tile shows only one channel, red, green, or blue. This helps us to see how much each channel contributes to the full image. For example, red is quite strong in skin tones. Green often dominates backgrounds or clothing, and blue is generally weaker but can highlight shadows. With thresholding, I set a limit. Pixels brighter than the limit stay colored, and everything else disappears to black. I set all 3 sliders to the same cutoff, but notice the results are not the same. In the red channel, my face shows up more strongly. That is because brown skin has a lot of red intensity, so even with the same threshold, more pixels in my face pass through and stay lit up. In the green channel, the face looks darker and less detail comes through. Instead, detailing of the shirt and background are highlighted, because those areas reflect more green. In the blue channel, most of the image has already gone dark. Blue values are weaker in normal lighting and skin reflects less blue, so fewer pixels pass the same cutoff, hence it's patchier. Here, I've converted the snapshot into 2 different color models. The first one is HSV, which stands for hue, saturation, and value. Hue represents the actual color, saturation is how strong that color is, and value is the brightness. Because of this, my pink shirt looks more vibrant. The saturation makes the pink stand out more strongly than in the original photo. The second one is YCBCR. This model splits the image into brightness called Y and 2 color different channels called CB and CR. Since brightness is handled separately, you can see my face outline and shirt details more clearly even though the color looks softer. You'll also notice the yellow star on my shirt looks blue here. That's because HSV and YCBCR don't display the colors in the same way as the original. Instead, they remap the color information into different channels, and when those channels are shown as RGB images, some colors shift. So the star hasn't actually changed in reality, it's just being represented differently in this color space. After comparing these results to the RGB thresholding in step 7, the differences are clear. In RGB, each channel shows different things. Red makes my face stand out, green highlights the shirt and background, while blue quickly fades to black. RGB thresholding can look patchy since each channel highlights different details, while HSV thresholding exaggerates small color variations, making it even noisier in the background. YCBCR is cleaner since it separates brightness from color, so my face outline and shirt edges are clearer, although details are lost in the background. To improve results, I could use other color spaces like lab or apply adaptive thresholding on grayscale or the Y channel. These methods give smoother edges and reduces noise compared to simple fixed thresholds. Now moving on to face detection, I used the face mesh model from the ml5.js library. This model gives me hundreds of facial landmark points. From those points, I calculated a bounding box that neatly surrounds my face. This box is then cropped out from the snapshot and placed in its own cell of the grid, so we can apply filters just to the detected face region. Once the face is detected and displayed, I can use the keyboard to apply different filters. Key press 1 converts the face to grayscale, reusing the same logic from earlier. Key press 2 applies a blur, showing how blurring can be used for privacy. Key press 3 allows an HSV color conversion just like in the earlier task. Key press 4 is pixelation. For this, the face is first converted to grayscale, then the image is divided into small 5x5 blocks. For each block, I calculated the average pixel intensity and repaint the whole block with that value, resulting a blocky, low-resolution version of my face. That concludes the project.